Morning, everybody. All right, lots of parties last night, I take it. Let's try that again. Yeah, lots of parties? Good parties? Cool. Well, good morning. Much better. Welcome to Malware Hunting with the Sysinternals tools. My name is Mark Rasinovich. And this morning, I'm going to take you on a tour with the Sysinternals tools for analyzing and cleaning malware off of systems. And this quote nicely summarizes the whole motivation for this presentation, which the sad fact is that a significant percentage of malware that people are running into today is not detected by antivirus. And that's because the antivirus companies need to find the malware and analyze it and then generate signatures and then push it out. So there's a lag between the time that the virus appears in the wild and the time that you get it cleaned. You can see this is from a Google report that just came out a few weeks ago, where they've got a technique that uses reputation-based heuristics to identify malware, and they sampled 10,000 pieces of malware they found just sitting out on the web and found that less than 40% of the binaries were detected at the time they found the binaries by major antivirus engines. So this is really the reason for why you might need to use the Sysinternals tools to go clean malware off a system or analyze it. How many people, by the way, have been infected by malware at one point or another? Wow. Okay, how about your family members? Have you cleaned malware for family members? Okay. How about, how many people are here today because you've got malware right now? Anybody? Yeah. I'll clean that off for you if you let us see your browser history. Yeah. So what I hope to get across in this talk is to show you some tools and techniques for going about determining if you've got malware, figuring out where that malware is, what it's doing on your system, and then cleaning it off. The tools that I'm going to show you are tools that are used by professional antivirus researchers as well, actually, but they use them in the context of a kind of first phase reconnaissance of an infection, where they'll use the tools to get an idea of how the malware operates and then use other tools like debuggers, disassemblers, tracers to go and dig deeper so that they can find the signatures. But just with the information I'm going to give you here, as you'll see with the demonstrations I have, you'll be able to clean or detect malware of the most common types. In fact, I've got samples of some of the most common types. Now, there's antivirus solutions out there on the market. Here's one. It's called Sysinternals Antivirus. I think I don't know how to feel about these kinds of things. Proud or dismayed or disturbed, but there's an antivirus engine called Sysinternals Antivirus, and don't use it because I didn't write it. And it's really not very good because it's actually malware. And what really pisses me off about this thing is they don't even link to Sysinternals. So the steps that I've got here for cleaning malware off a system are the steps that I came up with back in 2004, 2005 time frame. And back then, malware was operating quite differently than it is today, or large segments of malware anyway. Back then, malware was just infesting systems with adware, spyware, crap popping up everywhere, downloading tons of more spyware. So you'd have these spyware downloaders, and they'd make the systems boot really slowly and take forever to log in, and have pop-ups everywhere. Very noisy types of malware. And the formula that I came up with was first disconnect from the network. And the reason that I came up with that is because of these downloading pieces of malware, I'd start cleaning and analyzing a system, and the downloaders would start pulling down more malware while I was in the process of cleaning. And so I couldn't keep up with what was going on. So disconnecting from the system would stop the malware from the system from getting reinfected or infected with more malware. But another reason why even today with the more stealthy kind of malware that doesn't do this kind of pulling down stuff actively is that if you detect malware on a system, you want to disconnect it from the network so that you can stop the exfiltration of data off the system. So you're already probably losing data. You might lose more of it. So disconnecting from the network is one of the steps in the process. Next, this is the reconnaissance phase. What is going on with the system? Obviously, you've detected some symptoms somehow. So you've seen rogue network traffic coming off this thing. You might have seen a pop-up. Apps don't launch. is to identify which processes are potentially malicious. And then once you've identified them and have some confidence that you've identified them, then terminate them. So get them out of the way so that they're not active and interfering with the rest of the cleaning process. Then find the places how they auto-activate, delete those, and then go delete the files just as a final precaution. In this process, it's not necessarily going to be a complete process. You're not necessarily going to identify everything, all aspects of the malware. So this is why I go as far as saying delete the malware files even after you've deleted the activation points, because in the worst, in the best case, you're just cleaning crap off your computer. In the best case, you might be breaking malware that you haven't completely cleaned. So if you left the files there, it might still be operable, but you deleting whatever you see could disable it. And then finally, you might have missed something. Malware might be coming back. So rinse, lather, repeat. So reboot the system, look for the symptoms that you saw the first time, and if you don't see them, then you might be good to go. Now, I want to make a clarification point here, because a lot of people have this philosophy of, if you have malware on a system, wipe it. That's just security 101, they say. Wipe the system. Don't try to clean malware off it. I have more of the principle of, let's be pragmatic about it. If you can have some confidence that you've identified the malware, then clean it off. Especially in the case where you might have your mom with tons of stuff on her system, and if you've got a good idea that you clean the malware off, better save the wiping of her system and everything that she's got on there rather than face the wrath of your mom. And I know that even big companies follow this approach. They'll have domain controllers, for example, infected with malware, and the cost of flattening those domain controllers, basically rebuilding the domain, is so high that they will rather have experts come in and say, yeah, we're confident, we understand it, and wipe it. How many people have worked at a company where you've had a domain controller with malware on it? Let's see. Anybody? Anybody? Nobody? All right. Oh, there's one person over there. And did you flatten your domain? No. What? I was just kidding. No, no, that's okay. All right, let's talk about identifying processes first. And again, this is a list that I came up with for characteristics that identify malware, again, back in 2005. Processes that have no icon in their image, that have no description or company name in their version information, so they're kind of anonymous. They say that they're from Microsoft, but they don't have a valid digital signature, which I'll explain what that is in a minute. They live in the Windows directory or the user profile, as opposed to the common place where most programs, at least pre-modern phase, got installed in the program files directory. Or they're packed, which means compressed or encrypted, and I'll talk more about that later. They include strange URLs in their strings, or they have TCP IP endpoints open to Russia or China. Or they have suspicious DLLs hosted within them, so they're a benign process that's a host carrying malware. This list of characteristics I thought was going to be obsolete in a few years after I came up with them, but it turns out the sad state of situation is that most malware still identifies itself by meeting at least one of these criteria, in fact many. And you'll see the examples that I show you today, almost all of them exhibit more than one of these, and the sad fact is that they don't need to do things to take themselves off this list, because it's so easy to spread and so easy to stay kind of hidden in plain sight with this that they don't need to, they're going to do the bare minimum of work. How many people debug or look at systems with Task Manager? Wow, it's a bold admission in a Sysinternals talk, because first of all, you're kind of walking through a room blindfolded when you're using Task Manager, but second, I've got a better tool that I'm going to show you. It's called Process Explorer. Some people call it Super Task Manager. It has lots of troubleshooting capabilities. In fact, that was my original goal with this, was to help you debug DLL problems, file lock problems, hung process problems, and in fact I've got a session this afternoon which is all about using Process Explorer for those scenarios. But what I'm going to focus on here is its malware cleaning capabilities. Let's pull it up. Oh, by the way, this is not a disclosure. This is what blue would look like if you installed a third-party start menu. So let's go back here. Oh, by the way, want to mention Sysinternals tools. If you haven't been to the website, here's Sysinternals tools website, where you can download the tools. I actually updated some of the tools that I'll show you today, auto runs and SigCheck, this week. And there's a tool that I'm going to be using called Zoom It here. And the reason that I was playing Daft Punk, how many people like Daft Punk, by the way? Yeah? The reason I was playing Daft Punk is if you listen to the beginning of the song,
buy it, use it,
listen.
break it, fix it, trash it, change it, melt, upgrade it, charge it, point it, zoom it, press it.
Zoom it. There you go. Shout out from, you heard it. I sent him an email thanking him for that, but he hasn't responded. I think he must be busy. Anyway, so back to Process Explorer and the process view, which looks a little bit different than Task Manager's view. The first thing you can see is its tree structure, which shows you the parent-child relationship of processes. And for example, you can see that down up here in this section, the childs of this service host process, this service host process is going to be the background tasks infrastructure service. This is where you're going to see in now Windows 8, when you launch modern apps, they're going to be a child of this thing. But for the most part, what you'll see is that the parent-child relationship can tell you something about a process, because every child of services.exe, the service control manager, is going to be hosting a Windows service, which I'll talk more about later. So in the case of malware, it will show you, for example, if you see malware as a child of another process, that parent process might be infected with malware itself. You also see these colors. Besides the icon information that I mentioned, the description, the company name, all pulled from the version resource, you see colors. First colors you'll see are these blue rows. And the blue rows, those are special kinds of processes. Those are, anybody? Boy processes. No, those are not boy processes. Those are processes running in the same security context as Process Explorer. The pink processes are hosting Windows services. The white processes are anything that doesn't match any of the other filtering criteria. And the blue processes are ones that are called immersive or modern. They're able to operate both in the old world and the new world. We come down here and you'll see that there's another couple processes here in a dark purple color, and I'll explain what that is shortly. One of the things you can do when you see a pop-up is use the window finder, which is up here, to identify the owning window. So if I say who's the taskbar owned by, it takes me and says, well, Explorer does. This is a way, if you've got a pop-up, you don't know which process it's coming from, you don't see any that look like malware, you can figure out which it is. And there's also a right-click search online, which has been adopted by the Windows 8 Task Manager. And the search online will do a search with your favorite search engine. Oh, yeah. With your favorite search engine. And show you information about those processes. Now, the thing is, a lot of times that doesn't work anymore because malware either picks random or pseudo-random kind of names, and so the searches won't come up with anything. In fact, almost all the malware we see these days does that. There's also refresh highlighting. So some other colors you might see are if I create a process like Notepad, you'll see Notepad. No, I don't know where it came up there. Let's close that. Let's do Notepad. And down here, what showed up in green was Notepad, and when I terminate Notepad, it'll show up in red. There's a problem with that refresh, though, is that it's refresh based. It's every second. And so if you run a short-lived process like ipconfig, there it caught it. Actually, ipconfig spews so much stuff now, it's almost inevitable that it'll catch it. Okay, never mind. Oh, that time it didn't catch it. So you'll see that processes that live between the refresh rate won't get caught, and I'll show you how to catch those later. There's also tooltips. The tooltips can be useful for looking inside of processes to see what's hosted within them. So I mentioned that the Windows service processes, the ones that are pink, are hosting things, and I already showed you the background process launcher, but you have tooltips here on these. If I had a DCOM launcher, you would see a child of that, which would be the DCOM server. If I had a run DLL32, which I can create by launching a control panel applet, I do the window finder to see who this is, and then it's a run DLL32, and you'll see that the process is this run-DLL32 target, timedate.cpl. So this is a way to look at inside of a process quite conveniently. A lot of malware hides itself in run-DLL32. There's some features that are new. One is a timeline view. The other one is an auto-start location view. I'm not going to spend time on those here because I'm going to focus on a different way of looking at auto-starts, but this is something to be aware of. Just really quickly, how does Explorer get launched? If I go look at its auto-start, it's configured as winlogon shell, and that's why it gets launched when you log in. And so you could go change that if you wanted to, which malware we've seen does occasionally. You want to look a little more detailed at the process, double click on it. And by the way, there's a process here that is a little fishy because it is sitting here and it's purple. I talked about coming back to the purple color. I mentioned packed earlier. Purple is Process Explorer's highlight color for a process that looks packed or encrypted. And the reason that processes are packed or encrypted is typically, not always, that it's malware that is using obfuscation techniques where it will load into memory and unroll itself. The reason it remains compressed or encrypted on disk is that it makes it harder for antivirus engines to get reliable signatures for them because they'll use different encryption techniques or compression every time they get generated. And we've got a couple of those here, these WinHost processes. And if we take a look at them, they're not matching any of the other criteria that we've mentioned. Well, actually maybe a few. Let's see. The command line or in the path show that it's sitting in the Windows directory, but this has got a kind of a legitimate Windows sounding name, WinHost. It says it's from Microsoft. So the kind of clues here, suspicious clues, are that it is purple. So we're going to dig into that a little bit more closely by taking a look at its signing status, which you can do here. Let's talk about signing. Almost all Microsoft code is digitally signed, and most third-party code these days is digitally signed. So when you see something that's from Microsoft, you can go to the Process Explorer and say verify. And this will update the signing status up here, which in this case says no signature was present in the subject, meaning there is no valid digital signature on this, which is another big clue that this is probably malware that's masquerading as a Microsoft process. Like I mentioned, you can see the auto-start location here. This is configured in the run key. So that's a convenience there that will show you that this thing is configured to auto-start. But there's other ways to look at the digital signatures too. And when I clean malware off the system, what I'll do is say select all verified signers here, add that as a column, and then go to Options, Verify Image Signatures, and what Process Explorer will do is check the digital signatures on all the processes. So this is, then I sort, and I see down here that I do have some processes, Zoomit, for example, the test versions of Sysinternals tools, as well as these WinHosts, that are not digitally signed. So those are the ones that I would potentially go and take a closer look at. Note, some people say, hey, when I'm running Process Explorer like this or auto runs, I see connections to the internet. What's going on? This is checking for the revocation of digital signatures, which is done automatically by the signing engine. So you will see that reaching out to CRIL or certificate revocation list servers to see if those have been revoked. And there have been examples, several over the last few years, of malware being signed with digital certificates, legitimate ones, that had to be revoked. And that you wouldn't know that those signatures were revoked if you're disconnected from the network. So this is a downside of disconnecting from the network. What I also do when I'm scanning a system for malware is run a tool called SIGCheck, another Sysinternals tool. SIGCheck is just a tool that will show you digital certificates. And the way that I run it on a system is to use the -S, which is the recurse switch, the -E, which says look at anything that is executable, no matter what the extension, because we've seen many examples of malware that will give itself a JPEG extension or a .text extension to hide, but it's really an executable image inside. And this will ferret that out. And then -U to show only the unsigned executables. Well, let me do this without the -S. And the only one that I find in the Windows directory is WinHost. Now, I found other things here, unfortunately, in the GAC And the GAC is a place where I've been suspecting malware to place itself to hide with all the unsigned images that go in the GAC over time. I mean, it's a hive of scum and villainy in there in the GAC. And it's a great place to hide, but I haven't seen anybody take advantage of that yet. So anyway, I would check the Windows directory and the Windows System 32 directory with those switches, as well as the program files directory. Strings is a utility. Let's talk about strings. If you've got a process that's suspicious, another way you can take a deeper look into it is come to the process view and go to the strings tab. This will show you printable strings inside the file. One of the problems with this, though, is that if the image is packed or compressed, then you'll only be seeing the strings that are in the on-disk image, which will be garbage. That's where this memory button comes into play, which will show you the strings in the image as it's mapped into RAM. So this is how this process is unfolded. And then what you want to do is look for suspicious URLs. There's one right there. So this is actually process is shaping up to be quite suspicious at this point. And I think we can confirm that it is probably malware. Finally, there's another view, the DLL view. When malware is hiding inside of a legitimate process, what you can do is open up the lower pane with the Control D view. You can add the verified signer column to that as well, and check for unsigned images in processes that are hosts, and you can see that, well, the executable image itself is considered a DLL in the case of Process Explorer. And that's where another tool called list DLLs from Sysinternals -U star will dump any unsigned DLLs in any process that it's running. So it didn't find any at this point. Finally, now that we've identified that Win host, it looks really suspicious. What do? Kill it, right? No. That's inhumane. Put it to sleep first. Now, the reason that I've got that advice, it comes from, I haven't seen this in a while, but 4 or 5 years ago I saw it quite a bit. The buddy system was in play. Watch when I try to kill this Win host right here. What happens? Now, let me turn on the refresh rate, the highlight duration, so that we can see this thing. Let me kill this guy, this one. I've got actually a few of them. Oh, and then another one pops up. And if I kill this one, another one pops up. So these are using what I call the buddy system. One is watching the other guy's back, and if the other one goes down, he's going to revive him. He's going to go take over the paddles and zap him back. And so it becomes very hard to go cleaning the malware off a system when you've got this buddy system in play. But you can suspend them, put them to sleep. So I'm going to suspend all these guys. And there's 4 of them. And at this point, actually sort by this. Now, I simply, I love the sound of that new bell. Actually, I'm going to turn it off. Love is in a sarcastic kind of love. So now we've cleaned up the active processes. We're ready to move on to phase 2, cleaning the auto start locations for this piece of malware so that it doesn't come back. How many people use msconfig to go cleaning off auto starts? Let's see you raise your hands. So I'm surprised that you'll raise your hands after I made fun of you the first time. msconfig, now I have to say though, there's been a tremendous amount of work done on msconfig in Windows 8. Have you used it? Anybody used the msconfig? Let's go take a look. So we've got the general tab, that looks the same. Here, let's go to startup and check out wow. So tremendous amount of innovation and reimagining here in msconfig. What I'm going to do is use a different tool called autoruns. And this is another Sysinternals tool. Let's run autoruns. And by default, it's going to scan my entire system and show me all the files that are configured to auto-start or load inside of processes like Explorer or Internet Explorer or Windows Media Player or whatever the Media Player modern one's called. And what I want to do, and this is going to take a while because it's actually reaching out to group policy settings, scripts that are on Microsoft's CorpNet, and I'm not connected to the CorpNet right now, so you can see here's one, this bdeploy script here. What I'll do to kind of get rid of the noise, let me press escape and see if I can get control of this thing, is, if the network behaves with me. Okay, we had to wait for those threads to clean up. And I'm going to say hide Microsoft entries and verify code signatures. You can also see all the places auto-run looks by checking that. But with this, I'm going to filter out anything that is Microsoft that is digitally signed. And at this point, I see things that aren't. And showing up in red, images that don't have valid digital signatures. And any images that are not Microsoft showing up just as white. And the things you're going to want to look for are, of course, the red things. Anything that's yellow means that auto-runs can't find the image. So these generally aren't bad. In fact, there's some just locations built into Windows where there's kind of orphaned pointers off to things that aren't there. So no need to be too concerned about those. For those that are showing up, though, and by the way, there's different ways to look at this, like here's the logon location. Here's one, the Windows host run that we saw, and what you can do at this point is take a look at when it was made. So I made this a while ago. You can see its version information. You can jump to the location in the registry where that's configured. You can jump to the file system location. You can search online for it, or you can look at the properties for it. Now what I'll do at this point is uncheck it, and that basically disables it. There's a few more things that I want to point out with auto-runs it's able to do. It's able to scan offline systems, so you can load registry hives of a system, so you boot off of Windows to Go, for example, or connect an external drive, and then point auto-runs at the root Windows directory, and you can scan it for auto starts and do your cleaning from there. You can also scan other profiles on the same system. So if you've got a situation where it's a standard user account that's been infected, you've got another admin account that hasn't been, you can do the scanning of that standard user account from the admin account to clean the malware off the system. And there's a couple new features I'll mention here briefly. One is that I added a timestamp column in about a month ago. So now we'll show you the last modified time for the entries, which can be useful in the scenario where you believe that you got infected just in the last few days. Now you can go look at timestamps and see if those correlate with the activity that you correlating with the malware. Also, there's an auto-runs C tool that I'll mention. This is if you're running in a corporate environment. Auto-run C, you can have it scan the same way that auto-runs does with the same filters, and you can even have it print out in CSV format so that you can scan your corporate networks regularly, pull them up into Excel, dump them into SQL or whatever, and be looking across your network to see if you've got suspicious auto starts showing up on your domain controllers. I mentioned don't delete the auto starts. This is just troubleshooting 101. Try not to do things you can't undo, because you never know if you're going to make a mistake and go, oh crap, I shouldn't have done that. If you just uncheck versus delete, then you're able to go and undo it. Sometimes things come back, so that's where we're going to use Process Monitor to trace activity. How many people have used Process Monitor? So quite a few of you. Process Monitor makes network tracing or system tracing relatively easy. In fact, I've got a slogan. It's called "When in doubt, run Process Monitor." It's actually Dave Solomon came up with that. Let's say it together. When in doubt, run Process Monitor. Okay, you're not very good at it yet, but we'll work on that. And let's just take a quick look at what we see. Timestamps, process name with a tooltip that shows us version information, operation, path, the result of the operation, and special information over here in the detail columns about the operation. We're going to spend some time looking at real malware, so I'm not going to take a close look at that, but just highlight a few of the features. By the way, when my daughter comes home from school with homework questions, I have her run Process Monitor first. There's process properties. If I double click on this, it looks a lot like Process Explorer, not by accident. So we see the path, the command line, parent process ID, start time, integrity, here's the start time, and the list of DLLs that are loaded into it. Filtering is a key kind of technique that you should master as you use Process Monitor to get rid of all the noise and focus on the things you want to focus on. And there's lots of different ways to do filtering. Like I can just right click on a particular entry, row, column, and say filter by that. Include it, exclude it, highlight it, copy it to that row to the clipboard. Exclude items before this, exclude items after this. So if I say this, and then I can click on the filtering icon and do more complex filtering up here, like company is, contains, and then say anything from Lenovo, for example. I could do filters for that. So lots of different ways to filter. The filter that's most useful for looking at a situation where you've got malware reinfecting a machine, or you've got an example where you can watch how a malware infects the machine, is category is right. Category is right will only show you modifications to the system. So we see that Explorer is doing some modifications to the user assist count registry value, and it's updating it with some information there. So you can see there's typically not a lot of modification activity going on in the system, but if you've got a malware infection, you're going to see that being impacted, as we'll see shortly. The last thing I want to talk about for Process Monitor before we move on is the process tree. It looks a lot like Process Explorer's process tree, except with a nice, cool difference, and that is that it sees everything. So if I do a short-lived process like ipconfig, which might not have been captured in Process Monitor, or Process Explorer, I can go down and see it right there. In other words, they can run, but they can't hide from Process Monitor. Alright, so enough preamble. So I've kind of introduced you to the tools with some pseudo malware that I've created that I'm quite proud of to get the feature feel for the capabilities of Process Monitor, auto runs, and Process Explorer. Let's take a look at some real cases now. I've got a bunch of real cases. The first one is a piece of live scareware called WinWebSec, and I picked this one because if you look at this from the latest Microsoft Security Incident Security Intelligence Report, you'll see that when it comes to scareware, WinWebSec is still currently the second most prevalent piece of scareware, and it's been the most prevalent up there floating around for several years now as really impacting people. If you go to this link down here, which I've got opened up in the browser, where did the browser go? Whoops, I didn't mean to do that. Then you'll see that WinWebSec comes with a whole bunch of different aliases. So it's one of those scareware engines that's skinned, and that's the way Sysinternals antivirus is also skinned off an engine like this. Let me pull up, let's get WinWebSec ready to go. This will come up in a second here, and when it does, I'm going to launch WinWebSec. I'm going to have Process Monitor watching, and we're going to see how this thing more aggressively takes over the machine over the next few minutes as I try to use the machine. Okay. Connecting, and so what I'll do is launch it right now, and it's going to install. I'll launch Process Explorer, and I'll launch auto runs, and so it's letting me run these things right now as it starts to scan my system, and it's going to, believe it or not, on this clean Windows 7 install, find a lot of malware. Believe it or not. It's going to get wound up here in a second. Okay. I promise. There it goes. Let's take a look at what it's finding while it's finding it. And I'm not sure why we're having these hiccups here, because normally it just blasts on through. Whoa. Keep my focus. All right, let me try this. I'm trying to zoom in for you. Here we go. Let's see what it's found. KBD, it's found Trojans. It's found Zotob. That's one that you might have heard of. Netsky, another one. It's found NSLookup. Oh, that's a really bad one. Ping. That's even worse. So you'll see that it's just making crap up here at this point. And I think, these guys have a sense of humor when they write these things. And so let's say, you know what, I'm done. I'm convinced. Stop. You're scaring me. Well, 23 infections found can lead to system crashes, slowdowns. But you know what? I don't really mind those things. I kind of live with them on a daily basis anyway. So I'm going to continue unprotected. Are you sure? Yes, I'm sure. Well, at this point, it's going to start to get unhappy with me because I'm not buying into the thing. Oh, you better turn on virus protection. Windows is now bothering me. Turn on now. No, I don't want to. Oh, there's no close button on that. Oh, by the way, let's see who's launching this. It is this thing down here, which is a piece of malware. It exhibits the characteristics we talked about, a lot of them anyway. It has no description and no company name, and it's sitting inside of the user profile instead of in the places where you'd expect it to see it in the program files directory. And the reason that malware is sticking itself in these directories now is because they don't need admin rights to write there. And so malware is becoming more and more standard user familiar. Well, so let's say that I'm just going to move this out of the way. I don't care about it. But at this point, it's going to get really irritated with me and launch Windows Update. No, that's not what it's supposed to do. It is going to come up, and there, it tells me calc is infected with something. And at this point, it's like my machine becomes completely unusable, and I'm forced to do something about it. Unfortunately, in this case, we're not able to run auto runs, even. So let's go take a look at how we'd clean a system like this. And the technique we're going to use is to boot into safe mode. How do you boot into safe mode? On Windows 7 machines, prior, it's as simple as rebooting the machine, pressing F8, and saying safe mode. On Windows 8, it's this big dance of going through PC settings and general and startup repair, and then picking, I really want to repair. No, I really want to do an advanced thing. Out of those advanced things, I want to do safe mode. So there's another way to do that, and that's just create a Windows 7 USB key and then boot that off the system, or Windows to go. So, and do it offline. Booting Windows 8 into safe mode is a IQ test on its own, so I generally try to avoid it. But now we've booted into... Oh, that's not safe mode. What happened here? Reboot. Oh, what I've done here is, before the system comes up, what is happening is that this thing actually doesn't write itself to the auto run key. So if we'd run auto runs, we're not going to be able to even see it write to any key. But when we reboot the machine, it's going to come right back. And the reason it comes back is that it is actually putting itself, whoops, continue unprotected, yes. It's putting itself in the run once key. And it's putting itself in the run once key here, as you can see, run once, on its shutdown. And the way that I captured this is I did a Windows process monitor, great, new database update, did a process monitor boot log. So if I enable a boot logging, what process monitor is going to do is install its driver, capture this shutdown, capture the startup, and then what I'll be able to do is save the trace, load it up, and see exactly what the malware did during the system startup and during the system shutdown. And that's how I captured this fact that it is writing itself to the registry during shutdown. So it's a case where auto runs wouldn't have shown us anything, but Process Monitor will tell us how this thing is getting activated with the run once key. It turns out that that is enough for me to know how to clean this thing off. Let's say that I didn't know where this thing was and can't delete the file for some reason. The malware is as easy to clean off the machine as rebooting the machine before it's shut down, because it doesn't get a chance to do its clean shutdown and write itself. Example of how malware is being even more stealthy by not persisting itself while it's operating, so that when you go and analyze the system, it's not going to show up. So killing this thing is as easy as rebooting into safe mode and terminating it from there. And let's take a look at somebody else's real example of rebooting into safe mode and cleaning malware off a system. This is a case of a friend asking a friend. How many people have been asked by somebody like, hey, come over, let's have a barbecue and a beer. Oh, by the way, you want to check out the kitchen PC? Oh, I want to show you some cool pictures. Oh, I can't because of malware. Maybe you could help me clean it off. Now, this is an example of that, where the friend has the friend look at it, and it's obviously infected with a piece of scareware very similar to what we just saw. The user tried running Process Explorer and Process Monitor, but it was blocked just like what we saw, that malware blocking processes. They tried going to Sysinternals.com to see if there was something they could run, and even Sysinternals.com was blocked. Now, when you can't reach Sysinternals.com, I say you give up on the PC altogether right there. It's just not worth using anymore. No, actually, you can. What they did is boot into safe mode. And when they booted into safe mode, they ran msconfig, saw nothing unusual. So this is actually a view of safe mode and how safe mode doesn't show you a lot of locations that auto runs does. They loaded up auto runs, and I've got that file here. And when they pulled it up, it stuck out like a sore thumb. There it is, randomly named, sitting in the run once key, just like we saw WinWebSec create, sitting in program data, the root of program data. So this one did have admin rights, but cleaning this thing off then was as easy as unchecking it, and they rebooted, and the malware was off the system. There's more aggressive forms of scareware now. Ones that actually make it look like the law enforcement is after you. So let me pull one of these up. And I've got some examples of screenshots of this new kind of scareware. Whoop. There we go. By the way, this one right here, it's so bold that it even asks you to elevate it to admin rights. Yeah. And I think that my mom would probably click yes. This one says we have detected spam, and this is the one that gets people. Because at this point, they're like, really? You know what? I don't even want to take the chance that I might have it on my system, because if I go to law enforcement or take it to Geek Squad or whatever, and they find that stuff on there, then who the hell knows what kind of legal crap I'm going to be dragged through. So let me go ahead and pay this thing off to get this thing off my system. Here's another one, going around Germany. Here's another one. Here's one that makes you buy something first. And here, look, they're even internationalized themselves. Here's another one in Russian. Here's another one from the FBI. FBI asking for your money pack payment. It's a little suspicious. The Department of Justice, they seem to like money pack a lot. And by the way, you can get them at your finer Walgreens, Kmart's, and so on. Let's go back to the one that I've got here. It's called Lockscreen, and lockscreen.ct. And what this is going to do is it's not the scareware type, it is we've taken control of your system and it's hostage. Here it is. At this point, I can't do anything. It looks like the start menu is there, but I can't touch it. The only things I can do are enter an unlock code that I've got to go pay for. And launch a program like Explorer, or Internet Explorer, boom, it disappears. I've got a second desktop running here with Process Monitor watching what's going on, and auto runs as well. And I can't interact with them because this thing has created a little window for the mouse that is exactly where that little entry dialog is. So I can't click anywhere. You can see I can click here. Watch this. I can't click on that. If I say window key M, then I can minimize everything, and it can see that kind of the boundary box right there. There it is, where I can draw. But what I can do is take a look at what we see in auto runs, and I also can open Process Explorer, and there's lock screen. It shows up with the purple highlight right there. It's got a Russian name. It's got a Russian description. It has no digital signature. And what auto run shows us is it's sitting there in a couple places, WinLog on shell and the run key. The problem now is that obviously I can't clean these things off without because it's going to stop me from even running anything. So the only way that I can launch this or clean it is to boot into safe mode. There's a few different types of safe mode. There's vanilla safe mode with networking, and safe mode with command prompt. Don't use safe mode, the vanilla one. Don't use safe mode with networking. The reason why is that this malware puts itself in places that those two safe modes will execute anyway, because those use the shell. So for example, this WinLog on shell right here gets executed. Safe mode with command prompt will skip the shell-oriented, the shell auto starts. So that was the one that you'll be able to clean the system off of. And I've got lock screen right here, booted into safe mode with command prompt. And you'll see at this point, I can launch auto runs, and it'll come up and show me the exact same thing that I just saw, auto runs by cheating on that second desktop. Desktops is a Sysinternals utility, and they pop up. Now these are the Sysinternals tools that are debugging unsigned. And at this point, I can clean the system like this, and then go delete those files, and I'm done with the ransomware. Here's another example of a real piece of malware. This one is what I call the case of the runaway CPU. This is a user actually sent me this case. They noticed that their fan, so they've got this monster, tower under their desk at home, and they noticed that the fan is out of control. It's really loud. It's like what they get when they play a game that's very graphics intensive. And so they're like, that's funny, I'm not doing anything on the system. It should be idle. Why is the fan on? They launch Process Explorer, and they suspect that it might be the GPU, because the only time that they ever hear the fan spin that loudly is when they're playing a game that's GPU intensive. Process Explorer has GPU support in it. There's a GPU column up here, right there. And if I run something that's GPU intensive, you'd see these things spin up. I can also add the GPU columns like this person did. They process GPU here, GPU usage. And I see a little bit of GPU activity from DWM down here. Where'd it go? DWM. And if I do things like move this around a lot, that's going to generate some more usage. Oh, where'd it go? It's running away from me. A little bit of usage anyway. And what they noticed when they ran is that there was a lot of GPU usage down here by this thing called Java avsked.exe. 100% of the GPU, no description, no company name. It looks very suspicious. So they killed the process. The fan stopped. How did the process get launched? So they looked at the binary. They uploaded it to VirusTotal, and VirusTotal said this thing was a Bitcoin miner. How many people mine Bitcoins in here? Nobody? Few people? Bitcoin is this currency system that is kind of open right now. Everybody can go generate their own coins by performing these complex hash algorithms on your hardware, your CPUs or your GPUs. The malware was still active. Even though they terminated that process, there was still something active, so they couldn't run auto runs. So they opened the registry and went to current version run, where they were hoping they'd find something, and sure enough, they found this sitting here. Something sitting inside of app data roaming systweak, something called tweaker, which isn't, again, it sounds potentially legitimate. They deleted this auto start location, and the problem was solved. I've got an example of a real Bitcoin miner piece of malware. It's called Vicenor. And where is Vicenor? And if we go take a look at the Microsoft report for Vicenor, it says it's a family of Trojans that use your computer without your consent to generate a specific digital currency known as Bitcoins. What malware authors are doing now, instead of taking you ransom and making you pay something, they're using your computer to generate money for themselves. Because anybody can go generate these Bitcoins, and all you have to do is configure what Bitcoin account the GPU usage should be counted towards. And so the malware downloads it to your computer, connects to their Bitcoin account, and starts generating coins for themselves. So big botnets now are enlisted for the task of generating money for these guys. This Vicenor, unfortunately, it's a GPU-based miner, so we're not going to see it consume the CPU, and I don't have a GPU sitting inside this virtual machine. But here it is, and what it's going to launch as a child process is the miner D process. This miner is the miner process for Bitcoin. And if we take a look at miner D, its command line options, you'll see that here's the Bitcoin account. ispilledsoda.ru is what this goes to. So I go to, I haven't been to ispilledsoda.ru. ispilledsoda.ru. And apparently that is not active anymore, although it has been found in other pieces of malware. Here, Threat Expert says that they've seen this account being used. Now, what is the account password here? You can see the password is X, and the username is theirfz.1. So if we wanted to, and that account was still active, we'd have access to that Bitcoin account. Unfortunately, we don't. But this is a standard piece of Bitcoin malware. There's the reason that I don't see activity, like I said, is this is GPU-based miner, but there's also CPU-based miners. So what you'll see is now, even on systems without high-performance GPUs, that Bitcoin mining can be done on those GPUs. Of course, it's a lot less efficient. But when they're using your computer and not theirs, that's okay. I'm going to get this thing ready to go while I come back and talk about another case. And this one is the case of the unexpected FTP connection. So this case actually came into Microsoft support. This was a corporate customer. Customer detected through some of their network monitoring that a particular server, which was an Exchange server, was making outbound FTP connections. Now that's not suspicious, is it? Forefront, to make matters worse, after they detected these outbound FTP connections, they went and looked at their antivirus logs and saw that Forefront Endpoint Protection had cleaned some malware off the machine. But the thing was still making outbound FTP connections. So they had a problem on their hands. What support had them do was capture a process monitor trace. And then send it into support. Let's take a look at that trace and how support figured out what was going on. The first thing they did was said, okay, so we've got potential outbound FTP. Let's take a look at the process tree and see if there's any processes that might be generating outbound FTP. Anything that looks like it could potentially do FTP activity? Anything? Do you see anything that looks like it could be FTP? Yeah, there's an FTP right there. Now they look at the command line for FTP, which I can do right here. And they'll see that FTP, what it's doing, this -I or this -S, says go execute this script. And the script that this thing is executing is called J. What is J, they wanted to know. And where is J? Where can I look at it to see if this thing is really, something malicious? Maybe this will give us a clue. So what they did was set an include filter for this, and then search this trace for J. And you can see this creating J in a particular directory called I98292. You can see it reading J right here. It's a 58-byte file. So they had the customer go look to see if J was there, and J's not there. So no evidence left behind of what the script is doing. Whether it might be part of some piece of software, legitimate software they got on the machine, who knows. So they went back to look at what launched the FTP process. Let's go take a look at its parent process. So the parent process of this FTP is this command prompt. And we take a look at this command prompt's command line, and you can see that it's launching another command prompt, which is then creating a directory, a different name, because we picked a different one, I9925, changing directory into that, deleting anything that's in there, then starting to echo stuff out to J. Let's see what it echoes out to J. So I'm going to copy this command prompt, this command line here, and what I can do, is I'm doing F3s and just pressing return to replace those with carriage returns. And now you can see the first line, open up J, pipe an open command, obviously aimed at FTP, into J. That's the URL that it's going to connect to. Creates a new connection, sets the binary mode, does a get of all the executables off the FTP server, deletes J, and then for every file that it downloaded, goes and runs, sticks them in a batch, pipes it to output to a bat file and launches them all. And then deletes the outputs of the batch files after it launches the batch files. So this is obviously just aimed at just downloading whatever the botnet herder wants to put on their FTP server so that this machine now pulls down the malware and executes it. What is this thing? If we do a lookup for this, there's a Sysinternals tool called Whois that will conveniently do lookups for you. And this thing is in, it's my house. No, it's not. It's not my house. I do happen to live in Bellevue. But the reason that we're seeing Bellevue is that there's a company there called Whois Privacy Protection that is protecting the true owner of that domain name. So we've got a dead end there. So what the support person did is go back to the trace and say, all right, what is this thing connecting out to? Process Monitor, besides catching file system and registry activities, also captures network activity. So if I disable file system and registry, or filter file system and registry output out of the trace, what we're going to be left with is all of the network traffic that this Exchange server is performing. And if we scroll through this, we can see that it looks like legitimate traffic for the Exchange server, but then we see here batches in between of random URLs. Well, there's 105. Let's see. Let's filter out anything with Exchange in it. Well, and the way that you can do this is a new feature, Edit Filter, and I can say path contains, and I want to do Exchange, because I'm not looking for any, I want to filter out any traffic that is, and I want to say exclude, that is the Exchange server's legitimate traffic. What I'm going to be left with are mostly outbound connections. And in here, I'm having bad luck. Here we go. 190. Well, the 192's internal 209. There we go. 209 dot. Oh, I thought I saw 29. 229. All right. What is 229? Let's do a copy of that. I'll paste it into Notepad. And actually, I pick a new IP address because there's lots of them to pick from. And then let's go to a site which will tell us where this URL is located, like look up ip.org. It's a good one, or net. Look up ipaddress.org. And let's see what this tells us. Actually, what is the that's not the lookup. Sorry. .net. Sorry. Oh, that's not the good one either. There's a whole bunch of these, unfortunately. And by the way, a lot of these are serving malware too, which is something to be aware of. Okay, so this one can't find it, but I happen to pick an unlucky one. Here's 105. I should have picked that 105 address we saw. That 105 address maps to this place in Morocco. The company has obviously no sites in Morocco, and so this is something that scared them. And the other IP addresses I just got unlucky point to Tunisia and China as well. So this thing was actually infected probably by multiple botnets, all using the same entry vector and putting the same kinds of malware on the machine to get access to the outside. And that's all visible in the trace here. So they ran, at this point, they said, well, wait a minute, what is the parent process for those transfers? Let me go find one of them. Here's this 105. Which process on the system is talking to Morocco? It's not even that FTP process, it's the SQL server itself, which the SQL server is not even supposed to be on the internet, much less, not even supposed to be on this box with this Exchange server, much less talking to Morocco. So at this point, what the support guy did was take a look at the SQL profile, the security, with using a standard script that said, hey, can I log into the SQL server using anonymous? And sure enough, SQL admin password was blank, and it was set up so you could do XP command shell and launch something from it. They went back to the customer and told them this. What the customer believed had happened is that at some point in the past, an administrator, for some reason, was doing something on that Exchange server, installed SQL Server, didn't realize that it was going to be on the open internet, had a blank password, had it with XP command shell, did whatever they were doing, forgot about it, left it there, and botnet trolls scanning the internet found the SQL Server sitting there on the wide open and infected it. And we're now launching these FTP scripts to go pull down and infect the system even further. At this point, Microsoft support said, hey, you should wipe this thing and move on, and that's what the customer did. So a good lesson there, make sure that you understand what you got running on your servers and looking for suspicious traffic. I want to conclude with a look at a very sophisticated piece of of cyber warfare, or cyber espionage, depending on how you look at it. Kind of a similar vein to what we just saw of corporate systems getting infected. This piece of malware, how many people have heard of Flame, by the way? So quite a few of you. Flame is associated with one of the most notorious viruses, or the most notorious virus in history, called Stuxnet. So to understand Flame, and I've got Flame ready to go, I'm going to give you a little bit of background on Stuxnet. Here, let me find Flame. Here we go. What I'm going to do is launch Flame while we're waiting, because Flame takes a few minutes to infect the system. And I've got to do it using this load library, because here's the main payload of Flame. It's this OCX file. And the way that I'll know that Flame, and I've got Process Monitor sitting here ready, watching with a category is right filter. The way that I'll know that Flame has fully infected is that there's a file that will show up in here called ccalc. So it'll show up right in between these two files, and it'll be there in a few minutes. So we're going to come back to that after I explain what Flame is. Stuxnet was discovered in 2010 when a company's computer, a company based in Iran's computer, was crashing during the reboot. And they thought they might have malware on the system, so they contacted their antivirus company called Virus Blokta, a company based in Belarus, and they said, we think we might have malware. This antivirus company takes a look at the machine, and lo and behold, they discover something that looks very sophisticated. Device drivers that are digitally signed with valid digital certificates that are acting as rootkits. They expose the story, they talk about it, and a few days later, Kaspersky, Microsoft, Symantec all discover more variants of it now that they've got something to look for. And the story breaks wide open in July of 2010 that a very sophisticated piece of cyber weaponry is infecting a bunch of machines on the orders of tens of thousands, almost entirely based in Iran. And that this piece of malware, as they research the behavior of it, is an amazing piece of malware. It's got, the way that it propagates is using 5 zero-day vulnerabilities in Windows. 2 of them to gain admin rights on systems where it doesn't have admin rights, making it clear that this thing was designed for lockdown systems, like you might have, say, in a nuclear weapons facility. It has 2 vulnerabilities that let it spread remotely on the network. And these are vulnerabilities not patched by Microsoft. It's got one that lets it jump from a USB key using an auto run, an infection of a link parser bug in Explorer, so it can hop off the key onto the system. And that's the primary propagation technique, they believe. Not only that, but it's got drivers that look like they're signed by Realtek and Micron, valid digital certificates by these 2 Microsoft hardware OEMs that happen to be in literally the same office park a few hundred yards from each other in Taiwan. So somebody has stolen these certificates somehow, either physically in that park or infecting both those companies and getting those certs out, and then sign this piece of malware. So it wasn't showing up as something malicious because it had these trappings of a legitimate piece of software. They then discovered that they had a secondary payload, which was another rootkit. Not for Windows, but for the Siemens SEP7 PLC, Programmable Logic Controller, which happened to be the same exact type of logic controller used to control centrifuges used by Iran's nuclear enrichment program and Natanz. And this rootkit inside of it, aimed at this, caused those centrifuges to spin faster and slower than they were designed to, at variable speed, to the point where they would burn out, all the while projecting back false information, telemetry information, to the operator on the Windows system that the centrifuge was operating normally. So what was happening is these centrifuges are burning out, Iran doesn't know what's going on, they start to fire or behead their nuclear scientists, and then it's still happening, so then they're really fed up, and then this story breaks out in the press, and Iran's like, oh, okay, we know what's going on. There's Mahmoud touring the nuclear weapons facility going, wow, Stuxnet, so it's got us. And then about 9 months later, Flame was discovered, also floating around the Middle East. Some people, even like Eugene Kaspersky, called it the most complex piece of malware ever discovered. This thing is also the biggest, 20 megabytes in size. with multiple engines in it. Ones that know how to monitor Bluetooth networks, ones that know how to turn on the webcam and record things, ones that know how to turn on the mic and record things, all very modular. Not only that, but written in the Lua scripting language. Nobody's ever seen malware written in a scripting language before. And it's got even more. So they put two and two together. There's some hints of the same code that was in Stuxnet in Flame, and people believe it's part of the same program. US and Israel collaborating in a program the New York Times said was started before Obama took office by Bush to sabotage the Iranian nuclear program, enrichment program. And Iran admits that they destroyed 2,000 to 3,000 centrifuges, that Flame was probably part of an espionage, intelligence gathering as part of the Stuxnet program to figure out what was going on inside of these networks so that they could then develop Stuxnet. So by recording what the scientists were doing, by watching them, they could gather intel to help with targeting their cyber weapon called Stuxnet. And what I've just launched is Flame inside of this VM. And there's cccalc.sys, 32.sys. Let's go back to process monitor. And at this point, and by the way, there's a couple things that are noteworthy about Flame. One is it's afraid of Process Explorer. If I had Process Explorer running, and which is why I didn't have it running, Flame would go away and hide and not activate. So, and it's actually rumored that it's the CIA that created Flame, so yeah, CIA, there you go. The other interesting thing is, it took me a while to figure out how to activate this thing once I had the sample, until I figured out, maybe I need to make it feel like it's at home. And seriously, that is required to make Flame activate. And then, so let's go take a look at Flame, what Flame is writing. So it's dropping here mscrypt.dat into MS Security Manager, this massive payload down here, which happens to be a SQL Express database. How many pieces of malware have you seen that use T-SQL to store configuration? And we'll also see it drop the messenger.ocx file and cccalc.sys, a few different parts of its payload. It also has an auto activation point that doesn't show up in msconfig. But you can find it in the process monitor trace. You can also see it in auto runs, but I'm going to just find it. Because what it does is places itself in a very sneaky part of the system. By the way, it was also afraid to zoom it, which is why I don't have zoom it running in there. Reg set value, HKey local machine, system current control, set control, LSA authentication packages. And here it is pointing at MS, there's the payload that we saw that I launched, the OCX file. And this is how it launches every time the system boots. A place that almost no other auto start location scanning tools will even bother to look at. But AutoRuns does look at that location. So that is using the Sysinternals tools to look at malware. And I want to spend just a couple minutes here wrapping up with a view of my state of malware these days. Because what I see are two kind of extremes of malware. There's the junk crap that we were looking at earlier in the presentation that is, hey, it's just hanging out there wide open. No strings, no company name, no description, no icon. Packed. Show up like with flashing red lights in Process Explorer because they can. On the other end of the spectrum, we've got this kind of stuff like Flame, which is getting more and more sophisticated. And it's just going to get harder and harder because what we have is a trickle-down cyber weapons thing going on where something like Stuxnet comes out, the malware guys see techniques being developed by China and the US, big funded kind of organizations, and they'll adopt the same techniques themselves to stay on a system and hidden. So it's going to get harder. The goal, too, is to prevent, which has always been the malware from getting on your system, but also to detect it. There's a new philosophy now we've got in the world of cybersecurity, which is assumed breach. You will get breached. Every one of you will get breached. FBI Director Robert Mueller said at the RSA conference 2 years ago, there's two types of companies: those that have been hacked and those that don't know they've been hacked. So, and by the way, now that the official time is over, some of you might know that I've written a couple of cybersecurity thrillers. I thought I'd share. One is called 0 Day. Has anybody read 0 Day? That's good to see. And then I've got a sequel to it that I came out with a few months ago. It actually talks about Stuxnet because Stuxnet happened right as I was in the middle of writing this plot. And I just want to show you really quickly a trailer that I made. And
Technology is the bullet. Everyone is the target. Trojan Horse, a new techno thriller by Mark Rusinovich.
Took me forever to make my voice sound like that, by the way. But there's one thing that I'm especially proud of. I don't know if you noticed, but the foreword was written by Kevin Mitnick. And a lot of you probably know who Kevin Mitnick is. He's one of the most notorious hackers ever. What amazed me, and I didn't even realize it until afterwards, is that I got him to open a document called Trojan Horse. And that... Anyway, I'm doing a book signing from 12 to 12:30 of all the books: Sysinternals, Windows Internals, 0 Day, and Trojan Horse, from 12 to 12:30. And I'll be back here in the same room at 1 o'clock for Case of the Unexplained. I hope to see you there. I hope you had a great time and learned something and clean malware off your systems. Thanks.